Okay, let's start the next topic of the chapter, allotropes of carbon. So let us understand what is meant by allotropes. The various physical states in which an element can exist are called allotropes of the element. Means the single element is available in different physical states. In different physical states or physical forms. So such elements or forms are called as allotropes. So here the carbon is available. Four different allotropes. One is diamond, graphite, Buckminster fullerene and graphene. Buckminster fullerene and graphene are recently discovered, so we have no much information about them, and we didn't discuss much about Buckminster fullerene and graphene. We'll discuss about the diamond and graphite. Diamond and graphite, as we know, diamond and graphite. So the structure of diamond and graphite, their uses. Then after we will go with other topic, hydrocarbons. Okay, let's discuss about allotropes of carbon, diamond and graphite. Buckminster fullerene. So diamond. So here I will discuss it briefly because you understand very well. Diamond. As we know, diamond is the hardest material in the world. Colorless, transparent substance and with extraordinary brilliance. Diamond is a colorless. Diamond is a colorless, transparent, with excellent brilliance. Or extraordinary brilliance. Chamak, can call it chamak. In English, can call the very brilliant surface, a bright surface. In Telugu, we can call it dagadagam merisipothunadi. Diamond is a quite heavy, extremely hard, as we know. Diamond is extremely hot. As in Telugu we have one sameta, Vajrani Vajrantune koyali. So to break the diamond, we require one more diamond. Right? Manchiki manchi, chediki chedu ani cheptaru kada ala. Okay? Diamond is a poor conductor of electricity. Poor conductor of electricity, but it is a good conductor of it. Diamond burns on strong heating to form carbon dioxide. So on strong heating, produce carbon dioxide. They show that diamond is made up of carbon only. The carbon dioxide, okay, since then. Structure of diamond. How the carbon atoms are arranged in a diamond. Why the diamond is the strongest material? Right? Why it is a poor conductor of electricity? So let us understand with the help of structure of diamond. A diamond is a crystal, is a giant molecule, a very big molecule of carbon atoms. Each carbon atom in the diamond crystal is linked to 4 other carbon atoms by strong covalent bond. The 4 surrounding carbon atoms are the 4 vertices or 4 corners of a regular tetrahedron. Regular tetrahedron means this structure is called as a tetrahedron. Tetrahedron. So here one carbon, second carbon, third carbon, fourth carbon. Here also one more carbon. Every carbon is combined with other 4 carbon atoms. Of 1, 2, 3, I will do 4. 1, 2, 3, 4. 1, 2, 3, 4. Then similarly 1, 2, 3, 4. Then 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. Then here so each carbon atom in diamond is joined to 4 other carbons. 4 other carbons. 1, 2, 3. Here 4. Here 1, 2, 3, 4. 1, 2, 3, 4. So like that all the carbon atoms are joined like this. All the carbon atoms are joined like this. 1, 2, 3, 4. This is the main carbon atom. 1, 2, 3, 4. Sorry. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each carbon atom is in a diamond is joined in 4 other carbons. 4 other carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. The 1 and 2, 3, 4. So first carbon 1, 2, 3. Like that. Whenever we calculate, whenever we join all those. So hexagonal or tetrahedron. So just I will show you here the picture how the diamond means the carbon atoms are joined in a diamond. Right? Let's see like this. So strong bonds exist between all the carbon atoms. So each carbon atom in diamond joined to 4 other atoms. To 4 other atoms. So structure of a diamond. Right? Strong bonds exist between all the carbon atoms. Structure of diamond. The black balls represent carbon atoms. See how the carbon atoms are combined with other carbon atoms. This is a simple structure. Arrangement of carbon atoms in the diamond. So due to the strong covalent bonds between the carbon atoms, diamond makes a very hard substance. Diamond is a poor conductor of electricity because of due to the sharing of electrons between the carbon atoms. There is no free electrons. It is a solid. Diamond is a solid crystalline structure. So diamond has no free electrons. So it is a poor conductor of electricity. So the compact and the rigid three-dimensional arrangement of carbon atoms in diamond gives a high density. The melting point of diamond is very high, being more than 3500 degrees centigrade. Melting point is 3000 is more than 3500 degree Celsius. This is because of a lot of heat energy is required to break the network of strong covalent bonds in the diamond crystal. So, due to the poor conductor, due to the strong, then why the strong diamond is because of diamond is formed by strong covalent bonds between the carbon atoms. Right? So this is about diamond. This is about the diamond. Then let us discuss about the other allotropic form of carbon. The other allotropic form of carbon is graphite. This is the simple arrangement of a diamond, the carbon atoms in a diamond. So let us discuss now about the graphite. So this diamond, graphite is another allotropic form of carbon. So graphite is a grayish black opaque substance. So it is a grayish black opaque substance. Good conductor. So before that, let us discuss the uses of diamonds. Diamonds are used in jewelry. We know very well. So harder than the glass. The tip of the glass cutter. The tip of glass cutter are made up of a synthetic diamond. Which is not good enough for making jewelry. Right? So then diamonds are used for making jewelry, as we know. Then a sharp diamond edged knife called keratome used by eye surgeons to remove the cataract from the eye. Diamond dyes are used for drawing thin wires like the tungsten filament of an electric bulb. All these uses of diamond because of its great hardness. So a sharp diamond edged knife, keratome, is used by eye surgeons to remove cataract. So much you know it. So graphite, the grayish black opaque substance, good conductor of electricity. Good conductor of electricity. Diamond. Sorry, is graphite. So graphite also is made up of carbon only. The carbon dioxide formed by burning graphite can turn, whenever we burn the graphite also releases carbon dioxide. So carbon, graphite, diamond, graphite have entirely different physical properties. Available different forms having different physical properties. These physical properties are due to the arrangement of carbon atoms in the graphite and in the diamond. Chemical properties of diamond and graphite are the same because of made up of carbon. When they were produce carbon dioxide. So let us know the structure of graphite. So in a diamond, carbon atoms arranged tetrahedral shape like this, tetrahedral shape. In case of graphite, they arrange hexagonal shape. 6 carbon atoms are arranged like this. So, 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 1, 2, 3, 4, 5, 6. Then 1, 2, 1, 2, 3, 4, 5, 6. Then similarly, hexagonal structure, 6 carbon atoms, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 2, 3, 4, 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So, like this, the carbon atoms are arranged in the graphite. Arranged in the graphite. 1, 2, 3, 4, 5, 6. One section. 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So like this, carbon atoms are arranged. Carbon atoms are arranged in between. Between these, some weak forces hold the layers of carbon atoms together. Flat layer of carbon atoms. So between the carbon to carbon atom, so there are some weak bonds are exist. There are some weak bonds are exist between the carbon and the carbon atoms. So the structure of graphite is a very different from the diamond. Graphite crystals consist of a layer of carbon atoms or sheets of carbon atoms. So each carbon atom in a graphite layer joined the other carbon atom by strong covalent bond to form a flat hexagonal rings. Hexagonal rings. So the various layers of carbon atoms in a graphite are quite far apart, so that covalent bonds can exist between the carbon atoms held together by the weak van der Waals forces. So this dotted line represents the weak van der Waals forces. So these hexagonal carbon atoms are arranged in hexagonal ring because of the strong covalent bonds. These are formed different layers between the layers of graphite, between the layers of carbon atoms of graphite. Waals forces are present. Due to these weak van der Waals forces joined by, so sheets like structure, graphite is comparatively soft substance formed by strong covalent bonds between the carbon atoms, and they form like layers. Between the layers of graphite, weak van der Waals forces are there, so it is a soft. Graphite is a good conductor of electricity because of has some free electrons. Due to the presence of free electrons in graphite crystal, it conducts electricity. The carbon atoms has 4 valency electrons in it. Now, in a graphite crystal, each carbon atom joined only 3 other carbon atoms by covalent compounds. See here, first carbon 1, 2, it is combined with 1, 2. If it is not one more, 3. But what is the valency of carbon? 4. Valency of carbon 4. So, but it has surrounded into 3 carbon atoms. Still some electrons are present which are not involved in a bonding. Such are due to these free electrons makes the graphite conduct electricity. Makes the graphite conduct electricity. So, coming to the uses. Sorry for disturbance. Coming to the uses of graphite. It is used as a lubricant and also used in graphite rods electrolysis process, and also used in making pencil leads. Right? Powdered graphite used as a lubricant for the fast moving parts of machinery. Then used as the electrodes in the dry cells and electric arcs. Graphite used for making the codes of our pencils called pencil leads, and also used in black paints. Let's see the structure of graphite. This is the structure of graphite. The black balls represents carbon atoms. Weak forces hold the layers of carbon atoms. Strong bonds exist between the carbon atoms in the layer. So strong bonds here. The dotted lines are explains about the weak forces between the layers. These weak forces are called as van der Waals forces. And uses, the lubricant oil in this can contains graphite powder, electrodes in the dry cell, graphite, and since the graphite does not melt easily, the tiles on the nose cone of space shuttle contain graphite. And coming to the next allotropic form is a Buckminster fullerene. So consists of 60 carbon atoms arranged in hexagonal rings and pentagonal rings. Hexagonal rings and pentagonal rings. So 60 carbon atoms. So forms like a football shaped spherical molecule in which 60 carbon atoms are arranged. So the allotrope was named Buckminster fullerene after the American architect Buckminster Fuller because its structure resembled the framework of dome-shaped halls designed by the Fuller for large international exhibitions. So dark solid at the room temperature. So the shape resembles the football. Let's see the structure of Buckminster fullerene. The ball shown in this picture represents the carbon atom The structure of Buckminster Fuller is smaller to the football, made up of hexagonal and pentagonal panels. See, 1, 2, 3, 4. The black column, the black colored one, observe that 1, 2, 3, 4, 5, and the white rings has 6. 1, 2, 3, 4, 5, 6. So has both pentagonal and hexagonal rings. So let's know about the graphite and diamond. We are going to make one. So still some properties are not explained about the properties of Buckminster Fullerene. Buckminster Fullerene, scientist name, dark pit. Then graphene is the another allotropic form of carbon, a very light material. So even the graphene is able to place on the flower. That much very light material is graphene, one of the allotropic form of carbon. So you want to more information about this Buckminster Fullerene and graphene. So please search in internet. This is about the allotropes of carbon. Some parts are different and also very easy to understand and important also. The structures are very important.